Hi, I'm Steve Bjork. I'm the author of Lambda Sharp, and today we're talking about Kinesis streams, Firehose, and SQS, in particular in the context of an event-driven architecture. So let's dive into it. There's lots of mechanisms by which you can connect the dots in your system. Event-driven architecture is a really nice pattern for architectures and how they scale. You have multiple choices, so that's I wanted to dive into today, provide some pros and cons for each, and then also show how you can then combine them together with a pattern that we've been using, which I nicknamed Gather, because it kind of follows that philosophy. You can also consider pub sub, and we'll take a look at that at the end. So when it comes to event-driven architecture, what you're trying to achieve is very, very simple. It's actually so simple that you can use the archaic diagrams that you have available in pretty much any drawing tool of processes, pipes, and storage, and more processes. Working with these old diagrams is kind of fun. It's maybe a little sentimental value. But at a high level, you have a set of processes that are emitting events. These can be actions that are being taken, content being modified, orders coming in, and you want all of these to go kind of linked into a central place. And then you want to do two things with them at a high level. One, you want to keep a record of them so that you have them. You can use them for analysis. You can use them for diagnostics. You can use them for replay in fault-tolerant systems. And of course, you want other behaviors to be triggered, handlers that get activated by these events. So it's pretty straightforward. It's even how we build, graphic user interface apps and so on, where you have events that then trigger behaviors. Here we're just talking about a distributed system, and so the rules are a little bit different for some of the aspects. So the first one that I want to cover, it's not the first one, was launched historically. So my phone is going to go off. Is Kinesis. It's a really cool service, and has been incredibly reliable until November of 2020, I think it was, when there was a massive outage. That aside, it works great. So have used alternative strategies. So with Kinesis, you create a stream, and then you put events into that stream. Each stream can have up to 2 consumers by default. You can have additional, what they call enhanced fan out. So you have additional consumers at additional cost, obviously, it can be received. But in our case, actually 2 is a pretty good number, because we can use one of the consumers to run a Lambda function that then writes to S3, and that does our archiving of events. And the other one runs over the exact same events. So both Lambdas are getting copies of the same events to emit them, so we can hook up handlers to that. So in this case, SNS topic. So let me just show you how that looks like in code. The first one is Kinesis stream. Oh, let me make this bigger, full screen. Excellent. And did I? Proper account. We're going to be deploying, just make sure. Yep. Okay, good. Okay, so the first one we're going to look at is Kinesis stream, and this is the Lambda Sharp module definition for it. And I'm just going to touch on some highlights. So hopefully this is big enough. Like I said, there's a couple of things you probably want to parameterize it on. One is for how long do you want things to stay inside the stream before they decay? So let's say the Lambdas are not running, events are coming in, they will not be stored forever. So you give it a retention period. By default, it's 24 hours, and you can extend it to significantly longer at additional cost. You also have a shard count, and I'll talk about that a little bit when I discuss pros and cons, but you probably want to parameterize it as well. Setting up the stream is pretty easy. It's just you say Kinesis stream, and then you give it these 2 optional parameters, which is how long do you want to retain data for, and how many shards do you want to have, which is part of the provisioning. We also have to give our Lambda function permission to subscribe to the streams, but that's pretty much the setup. In this case, we're also setting up an S3 bucket. This is where we're going to store things. It's going to be the same in all the modules since we always store in S3. We can get read-write access. This is a helper custom resource that just when we tear down the stack, it empties the bucket. So it's not necessarily, it's not usually needed in modules, but here for convenience. So since we're going to store data in it, otherwise when you try to delete the stack, it's going to tell you, oh, you can't delete it because the bucket is not empty. This will take care of it. And then we have a store function. And that store function, we subscribe it to the stream source that we defined above. Let me go back here. Resource stream. So that's what we're subscribing to. And we tell it to give us up to 100 records as a batch. So the Lambda function will be invoked with no more than 100 records. Could be less because it will not wait for 100 records. It will wait for a little timeout period. So if you have less, it will still deliver them. Delivery time is actually pretty good with Kinesis Stream, which is one of the nice benefits of it. Then we have a bunch of topics here that we're going to use for emitting. We'll just skip over those. And the emit function is also hooked up to the same Kinesis stream. And again, also with the batch size of 100. So this is the function that we in the diagram that is basically consume the events from the Kinesis stream and then emit them on the topics. Taking a look here at the store function. So this is just a generic, so Lambda Sharp has like multiple types of base class functions. This is a generic function that simply takes Kinesis event as its input and then string just as generic return value. It's not used, so I usually just return OK as a string. In terms of initialization, we need the RN of the bucket and then the S3 client, and then consuming information from the stream is actually pretty straightforward. We get invoked with process message async. So the stream, whenever it has either 100 events or enough time has passed, it will do the invocation. We receive them. In this case, I decided to, instead of storing each record individually that we receive, I actually take all of them, combine them into a larger record, and that's what I store into the S3 bucket. And actually, I create a compressed stream, and then I store it here in the S3 bucket with a put operation. There we go. And I got distracted because I just realized I should have deployed this. Large deploy, Kinesis, so we can see it in action. But we still have a little bit of time anyway, because we're going to go over the emit function. So as you can see, the request has a property called records. That's what we loop over. Each one of them contains the data as a memory stream. And we are just copying it here into a gzip stream. So we're taking all the records we're getting, we're concatenating them into a zip stream, and then we take that zip stream, and that becomes basically the stream that we use for the S3 put operation. And so that takes care of the operation for us. And then on the emit side, it's very similar, except in this case, so similar initialization, we read the names of the topics from our initialization. We can't concatenate records. Instead, we loop over the records and we use this helper method called run task, which does an asynchronous operation and kind of like scheduled into a Lambda function. And we'll just wait until all these operations are done before the Lambda function exits. Whenever you do background work, you have to make sure your background work finishes before your Lambda exits. As soon as it exits, your Lambda environment gets completely frozen. It's just stopped. So if you had a background task running as a thread, for example, it will just get frozen in place. So you have to make sure that you finish your work. One task does exactly that. It basically says, oh, you have all these asynchronous activities that need to complete before I exit, and it will wait for them to complete. If any of them have asynchronous errors, they will get reported, and so on, and you will see it as an error for the exit code of your Lambda as well. So one task is kind of like convenient when you want to just do a batch operation. Again, this is unbounded, and if you need something where you do it more in batches of limited size, may not be the optimal way. But here we know we only have a handful of topics, so this works quite nicely. Wonderful, the beep, which means our stack got deployed, and it emits a few things. And one of them is the ARN for our Kinesis stream. So I'm going to copy that. I click. Not doing me any favors right now. Okay, .NET run. And then there's a little app I provided as well called Send Events Tool. And it takes as a first parameter the ARN of a stream, a Firehose, or a queue, and then it figures out what it is and uses the right command. So I'm going to send some events to it. Success, 112 Kinesis record sent, just like a random number. And so now if I go into our AWS console and CloudFormation, I can go here and I look at the resources we created. And there should be the store function, and it has a log group. So we open that. And all that loads. Wonderful. I don't need the details, thank you. Okay, it already got invoked. And now you can see how this is the first invocation of the function. It received 100 records. It then took the 100, compressed them into the output stream. So there were about 57 kilobytes before, and it's only 3,800 bytes afterwards. So you can see how well, this is just a simple JSON records, but it compresses incredibly well. It's text, has a very highly repeating structure. Every JSON object we had the same properties. So compression-wise, these things are amazingly well to compress. Store them into our S3 bucket, and we're done. And then we got the next invocation of the next 12 records. And therein is one of the key attributes of Kinesis streams, is you cannot get to the next records unless you've successfully processed the previous ones. Almost like a file stream. If you have a bad sector, you can't read what comes after until you're going across that area. So you're either going to have to process them successfully or somehow store them somewhere else that you can follow up later on. Because if your Lambda keeps failing, it will never get the next batch until that retention window kicks in and Kinesis just forgets about your events. But then we have data loss. That's not a great place to be either. So quickly just going back here, and we should be able to go into the bucket. And then we can also in the bucket. I just did a very simple format, months, year, months, day. And then here we have the two batches that were received. And I simply use the event ID. So these don't have any additional ordering information in them. Again, application-wise, you may have to do different things. But this is a simple scheme for archiving everything successfully. And again, if your storage function starts to fail, you should be getting alerts and take action so that you can catch up and store everything back into S3 where it belongs. So that's the mechanism. Oh, sorry, one more thing. And I should keep this guy open, which is the sending of events. This is the creating records. So here's the function, and it's very easy. We just call put records. That was the ARN. It takes actually a stream name, not the ARN. So we just there's a little bit of string manipulation, and then we do a batch operation with all the records and just send them up. There's a limit on how much data you can send, but in this case, 100 is cannot exceed it. The data structure is just too simple. But otherwise, you may have to batch it. And actually, what we've done in our product is we have an accumulator that will see if a certain number of records have been accumulated, in which case it will immediately send them, or wait a certain period of time and then send them, so that if nothing is happening for a little while, it doesn't hold on to records too long. The reason we do that is twofold. One is to optimize batches, so minimum number of puts, because that's one of the billing aspects. But the other one is also throughput. So let's talk about some of the benefits and drawbacks, and we'll touch on it. So what is nice with shards is, like I said, the processing of the emit and the storing is happening concurrently. Those two lambdas are being triggered at the same time. And they will keep their own kind of like position in the stream independently of each other. So maybe if the emit is taking a little bit longer, or the store is taking a bit longer, one may progress faster than the other, but eventually they'll always catch up to the same position. They both get the same events, and they get the next set of events once they've successfully completed one batch of events. Within a stream, the events are ordered, so whichever way they were received, that order is preserved. And as you do successive attempts at reading the next batch, you will get that information in the same order if it's coming from the same shard. And that's important. Because going to the negatives, shards have to be provisioned. We saw that at the beginning, where we have to know how many of these shards we need. There's a limit on how much data you can push into it. It's about a megabyte per second that goes in, and about 2 megabytes per second that can come out. Hence why you can have only at most 2 consumers without running into shard capacity issues. Like I said, there's a fan-out option for adding for provisioning additional output capacity, but that's kind of like the name of the game. We touched on, if you have a failure, you can read the next. There's no built-in archiving capabilities. You will have to build your own. I chose to build a Lambda that goes to S3, but if you have a Lambda, you can put anywhere you like. And last but not least, when you have more than one shard, there is an additional piece of information. We make sure, let's see, it should have been here, partition key. This information here is something that gets hashed upon that identifies which shard these batch of records will be pushed into, and that's where they will reside, and that's where they will preserve their order. So it will not occur in the other shard. That is up to the sender to make determination what is the best way to load balance it. So if you're not careful, you could end up in a situation where you have one shard, even though you have provisioned enough capacity across your shard, one shard is getting underutilized, another one is getting overutilized. And that's if you use things like user IDs or something, and one user is very, very active. So you can't do that. You have to be careful how you organize it. Now, if you design your system in an idempotent fashion, and the order of events isn't that critical because it eventually converges onto the intended state, then you can pretty much randomize which shard you pick. It's kind of what I did here. Just pick the event ID of the first event that I saw that that I could put together, and that should give me a fairly good even distribution. Although conceptually it is possible one would get a lot more than the other. In general, it's not a problem we need to worry about. But again, keep in mind the partition key is there to load balance across the shards. And each shard can then invoke 2 lambdas. So if you have 4 shards, you may have 8 lambdas running, right? Because each shard will invoke the 2 attached lambdas concurrently, and the lambda infrastructure will make sure to increase capacity for those functions. Now, by default, retention period is 24 hours. I consider that severely not sufficient. That's a very short period of time before you start losing data. So that means that your ops team has now 24 hours to basically remedy the situation before data loss occurs. And remember, the time for remedying situation isn't just that you get the fix deployed, but that when the fix is deployed, it can actually catch up, right? Not that it's running so slowly and it still cannot catch up before it needs to be able to process an hour worth of events in less than an hour. Otherwise, it's falling behind and you will have data loss. So I highly recommend you extend this beyond, like 7 days or so, a period of time that you feel highly confident you will never run into. The other thing I highly recommend is compression. You saw that in the example where, in this case, I compressed after I received the data and I put it into S3. Nothing prevents you from doing the same thing writing into Kinesis. And you get an amazing level of compression. I mean, we just saw in the example, and it looks like I moved away from the page, so I'll just say it was about 60 kilobytes or so that we got initially in the batch, and then we wrote it down, it was 4 kilobytes. I mean, that's over 10x. 10x is a pretty good rule of thumb. The difference is 10 shards versus 1 shard, right? If you get to saturation level of 1 shard, you would have had to use 10 shards if you didn't use compression. So I highly recommend, if you can get away with it, use compression when you write into the shards. It will save you a massive amount of time, both writing the data, but it also saves you a good bundle of money. Not that Kinesis is particularly expensive, but at scale, anything becomes expensive. And this is definitely 10x is a great savings. Great. So Firehose should be a little bit fast to handle. It's just because there's a lot of things in common. The big difference with Kinesis Firehose, technically called Kinesis Data Firehose and Kinesis Data Stream because they introduced video as well. But Firehose is pretty uniquely identifiable in the console, so Kinesis Firehose should do. With the same idea, processes write into the Kinesis Firehose stream, and the Firehose, in this case, is actually hooked up directly to an S3 bucket. So it takes care of the archiving into S3. You don't have to worry about your own Lambda. So as a matter of fact, Kinesis Firehose cannot call a Lambda directly. What they do instead is they have I think I referred to as analyzer lambda. No, think of it, it's actually a transformation lambda. So Kinesis Firehose allows you to invoke a lambda with the data it's receiving, transform it, send it back to Firehose so that that's the data that gets stored. So we can use that to actually inspect all the records that go across, just send back exactly the data that we're getting, so we don't do any transformation, but we can emit events that we're seeing in the stream. So let's look at the implementation for that. It's a little bit simpler because we have one less component. So let me open the module. So we immediately initialize the data, the Firehose. We indicate how we want the data to go into Firehose. The Firehose can actually be hooked up to a Kinesis stream, but in this case, we are going to be doing put operations directly against it. And now we also need to configure it for how we want it to write the data to S3. That's taken care of by the bucket on here as a destination. The role on gives it the right permissions. And then also we hook up this processing function, which is a lambda that does the emitting of the events as they come across, so that we can then hook up other additional processing downstream. This is the role that we need to give to our Firehose instance. And as you can see, it basically has permission to write to the S3 bucket. So we need there. Oh, and permission to invoke the lambda. Never mind. It has two permissions. Writing to the S3 bucket, invoking the lambda. Bucket is exactly the same thing as before. We create a bucket, we attach to the custom resource to empty it out and on stack deletion. I should also deploy the stack, speaking of which. We have the SNS topics being created here. And then we have the emit function. And as you can see, the emit function is not saying that it is subscribed to Firehose because the Firehose is configured to invoke the emit function instead. And inside the function, let me scroll down to the initialization. Again, we read the topics we want to emit to. And then we get a Kinesis Firehose event request. It's hooked up like we did with Kinesis Stream. This is a generic Lambda base function, a Lambda sharp base function. And we go over all the records. We convert the records. They come in as base64 encoded. So there's some additional processing we need to do, because the difference with a Firehose is that Firehose will actually batch things together as data comes in. It sees it just, it's almost identical to a file stream conceptually, where you just write to it and all the things just get combined. It does still have these record boundaries at this layer, but once it's stored, they go away, which will be one of the pro tips later on. But again, we just loop over all the records. We get the data. We then check which operation was and then emit it against the appropriate SNS topic. And that's all we do. And then our response is, hey, by the way, the records I want you to store are the records you gave me. No changes here. So it's a pretty simple setup. So we're basically just inspecting the data and not modifying it. And that gives us the properties we want. Oh, it's still creating. So this is definitely slower. How long did the Kinesis stream take to be created? So the whole stack was about 2 minutes. Of that, probably the longest was the Kinesis stream, I would imagine. Kinesis stream, yep, minute 44. Right? No, that was the actual thing itself. No, Kinesis stream was only 8 seconds. Holy smokes. So it's good. What's taking here so long? Delivery stream, Firehose. Wow. All right. Well, that's creating. Let's go into the pros and cons just so we keep things moving. The cool thing with Firehose, which you may not have noticed because I didn't draw attention to it, is we didn't have to provision a shard. We didn't say, hey, I need 2 shards, I need 5 shards. What kind of capacity you need? There's no capacity planning with Firehose. That's why the name is really well chosen. It's you just go at it. However much your system is emitting is how much it will scale to absorb and then save into S3, take care of it for you. So that's really nice. You don't have to worry about the handling of archiving either, because that's just automatically handled for you. You can archive the data into variety different places. In this case, I was using S3, but if you look at the Firehose service, you can hook up also Elasticsearch and other things. Because of how it does what it does, your Lambda function will get called concurrently with these batches. That's how it scales up. So it doesn't have to necessarily order them exactly. The batches are still sequential, but they can be processed concurrently. However, it will never get past. It will keep repeating that batch indefinitely. I think they added some functionality that it can start bisecting the batch into smaller pieces so that it might be able to succeed in a subset of it, and then eventually skip the batch that wasn't successful. And that might be for Kinesis Stream, because thinking of it, actually, Firehose, pardon me, Firehose will store them in a different location in the S3 bucket as failed records. That's what happens when the Lambda comes back and you're like, oh, I crashed, run out of memory, just had another reference exception. Those records are considered failed and actually sent off to the S3 bucket in a different folder. Pardon me, that was misinformation. Because it always just does its thing. There's no worry about retention. There's no setting for it. And one of the problems, though, is when it stores the batches. So if you're sending JSON events and you don't put a separator character between the JSON events, they're literally just concatenated as strings. So it's really hard to use them after, for example, with Athena. So you would actually have to send them with, for example, your JSON with always appending a new line character at the end when you write it into Firehose to begin with, because you have, other than that transformation lambda, that's the only other opportunity where you could insert it. The problem with the transformation lambda is the lambda itself. Lambda has a 6 megabyte output limit, which means that if what comes in is already close to that limit and you're adding characters into it, you might actually not be able to emit it. Your lambda will just get terminated for having exceeded its output limit. And the solution then is to re-ingest those records, like basically having the lambda send them back into itself, into its Firehose stream, and now it's a different position in the stream. It works. It's actually how Lambda Shop Core does the CloudWatch logs ingestion, but it's not a nice way of doing it, and definitely something I wouldn't recommend for. So if you send data compressed and you want it to be analyzable by Athena, which is the Lambda Shop Core scenario, what you should be doing is send them compressed, store them compressed in S3, and then have a Lambda function in S3 that does the transformation and then saves back the records that are expanded with JSON object that you can query. So just keep it in mind, you can set up Lambda stores to trigger on S3 puts, which are automatically triggered by Firehose when it delivers the object, do the transformation there. The transformation, inline transformation, because of the 6 megabyte output limit in Lambda, is a really fragile spot to do it. It really takes some careful planning, and I struggle with it quite a bit. So I would not recommend it in order to achieve a reliable system. The other thing that is really quite significantly different is Kinesis Stream will invoke the Lambda function in about 100 milliseconds after the event arrived. It is freaking fast. It's a very low lag. And if you do the fan out, the additional capacity, it drops by half approximately. I think it goes to 60 milliseconds or so. So you get even faster invocation times. With Kinesis, not so much. You have an accumulation buffer window for how much data you want to accumulate before you basically do these put operations into S3, which are also triggering the Lambda function for the transformation. And the minimum accumulation window is 1 minute, which means that on average, you're going to be waiting 30 seconds before you get a batch and you can see events in it. So as a way of hooking up downstream systems, if you're okay with a lag, then that's fine, but just be aware of it. You will not have the immediacy. You will introduce up to a minute delay before the Lambda gets actually invoked with the payload, can see the events and emit them on an SNS topic. So we covered having all the records with an N at with the new line at the end. If that's just want to make sense, could always be the ASCII 0 character. That's also another great option for separating things later down. And then compress, you get the same benefit. So now that we deployed, let's take a quick look at just invoking it. So it should have emitted the ARN here as well. Perfect. So this is now a Firehose ARN. And we invoke our function again, but with Firehose. Oops. Oh, that was the role it emitted. Did I not emit the Firehose ARN? I did not. I just grabbed the first thing that looked like an ARN. Bad habits. Actually, I need to take it from the resources. Where's my Firehose? Oh, just to make life a little bit, oops. Did I just close my window? No. Nope, not at this. There we go. Okay, that's what I wanted to do. Delivery streams. I should have sort of, yeah, that's the one. Okay, where's my iron? Here we go. Oh, they don't have a little button for copying the iron. Okay. That makes more sense. Now it says iron AWS Firehose. All right, send some records. There's this guy. Don't need this guy either. We're back here. And we can now open the emit log group. So this is the Lambda function that gets invoked. Uh-oh. Oh, I just emitted it. That's why. I was like, oh, did it not work? But it's probably, that's exactly the lag I'm talking about. It takes a minute to show up. So it's still empty. So the while we wait here, other than to have silence, the cool thing with Firehose is because you don't need to provision it. It means also that if you're not using it, so if you have a very low consumption system, it's virtually free. One of the reasons why I chose it for Lambda Sharp Core, the base module, because you can just deploy it. You get the benefit of all the log ingestion, but only when it actually needs to happen. Otherwise, it just sits there, and if nothing is happening, it doesn't cost you anything. It's completely consumption-based, which is wonderful. Great, got invoked. Started sweating there for a second, like, uh-oh. Sure, I tested this. We received our 107 Kinesis records, and apparently I didn't do a whole lot of logging in this thing as we exited. And so, why is it not in my bucket? Did I not give it the right permissions? Looked like it was correct. Oh, yeah. I may have to investigate that and fix the sample. It should be showing up here. Again, saved by Firehose directly, gzip, because that's the format that we selected in the module. Let's see. This is the compression format. So you have different output formats. Parquet is one of them. Gzip, if you just want to kind of store it in S3. Then give this one more chance. Nope. All right, then I have to look at it. Okay, so that's Firehose. And last but not least, simple queue service. So this is actually precedes Kinesis streams by several years. Completely different way of processing, but it works equally well. It just, again, it depends on your application. So in this case, you would have your processes send it to a queue as opposed to a stream. The downside of SQS is because it's not a stream, having multiple lambdas listening and doing things concurrently wouldn't make any sense because they would be competing for events, and the event wouldn't be delivered twice to each lambda, but just if it was successfully processed, hopefully only once. Otherwise, you have another set of issues. That means in the use case that we want to apply it to, our lambda function, which is listening to SQS, needs to do both the storing and the emitting. And that, if you are kind of, if you like having minimal responsibility design, doing two things is not great. Which one we're going to do first? First the archiving and then the emitting. What happens one of them fails? And you have to redo the whole thing again. And so you have to make sure that it's idempotent and things of that sort. Again, for many problem domains, it's solvable. For others, it's a little bit harder. All right, one more time. There, I give up. Must not have checked that he was actually writing it as intended, which is great. It's like when you're doing backups and actually never check if the backups are successful. So, okie dokie, SQS. Here we go. So let's deploy this guy. All right, so while that's running in the background, let's take a look. Setup is incredibly easy with SQS. There's literally no parameters to just get it going. The only thing we need to make sure is that we have permission for a Lambda function that we can receive data from it. We, again, as before, we create the bucket arm. We create the topics that we're emitting on, and then we hook up our Lambda function to the queue, so that it gets invoked by it. In this case, we are using a different base Lambda sharp function. There's one for queues that's optimized for it, Lambda queue function, and we tell it, hey, this is an event. The one thing that gets me every time is it's not just an event in the queue, it's an event that was delivered by this one was just a straight up code. The scatter gather is where it got me. I'll get back to that. But it's basically, if you use something like SMS to deliver it, it's packed in another envelope, and you may not be thinking about it, and then it gets you because the format doesn't line up. Initialization, same as before. We read the topics. We also have to read the bucket because it's doing two things at once. And then when we process it, the right thing to do is you want to store it first. Archiving information, not having data loss is the most important thing. That's always what you should prioritize. So once we know that our data is hopefully nice and safe in S3, we can go forward and start and emit it here. Now, the Lambda sharp SQS base function, while you can receive multiple messages at once through a batch read operation on SQS queue, you only get invoked with one message at a time. And that was for simplification. That's simply because it's really designed for letting you think about these items in the queue as being independent. Order doesn't apply. And the fact that you're doing a batch operation versus of 10 versus just taking a single item shouldn't matter when you implement it. So if you wanted to do things like combine 10 records because you had a 10 items in the batch operation, don't use the Lambda sharp queue-based class, use the generic one, then you'll get the higher level container, SQS message container that contains all the records that were fetched in the operation. But normally, all you want to do is loop over each one and process it. In this case, if you were to fail on one, the base class is smart enough to identify that 9 of them were successful, 1 of them failed. It will acknowledge the 9 successful ones, so they will not be processed again, and only let the one that failed be reprocessed in a later attempt. So there's a lot of logic behind the scenes that is what is the most common use case for where it's useful. Okay, so hopefully this time I emitted the SQS. Yep, there it is. Okay, SQS ARN. Wonderful. Let's do it. So 112 records emitted. So let's go back to here. I don't dare to hit refresh for fear of deep disappointment that it still didn't work, which is probably the case. But I'll have it fixed. Okay, so let's go to our store and emit function, the log group in particular. And you can see there were multiple invocations, and that's because, again, queues don't care about order. It will push out whatever it can. So SQS, when it sees that it has a lot of data to process, it might just instantiate multiple lambdas so that it can feed that data to them as quickly as possible and catch up, right? So that your queue doesn't just simply balloon indefinitely. Let's take the latest one. And then we see got the mesh processing mesh, received event, stored event, and then it emits some. That's by the base class. There are some automatic success markers, how many messages were successfully emitted. So CloudWatch metrics are being emitted on your behalf, so you can actually see it, as opposed to just seeing how many batches were received for the Lambda, because that's a Lambda invocation. It will actually emit more detailed metrics around how many messages in the batch were successful and how long did it take to process it. And it does it over and over again because we get invoked once for each batch. So let's talk pros and cons. So the cool thing with SQS is similar to Firehose. It looks like I'm right on track, just about to get this guy together. Awesome. We didn't have to worry about provisioning. SQS will scale up to the capacity that you need. It's completely seamless. Also, it's less sensitive to failure in Lambda functions because compared to streams, it can skip to the next set of events. So it might invoke one Lambda, give it 10 events, messages that it received, and then invoke the next one, the next one, and the next one. Some of them are successful, some of them are failed. The ones that fail kind of go back into the queue and become available for the next batch again. So it might now be grouped in a completely different batch and read operation and invoke another Lambda. And it will just rinse and repeat until it drains all the messages in the queue. Oddly enough, there's no, you can configure your SQS queue to for how long you want to retain data. I looked really hard, and apparently there is no cost associated with it. I thought there was in the past. Maybe they changed it, and maybe I just misremember. So by all means, by default they retain data for 4 days. Extend it to 7, extend it to 14 days. Give yourself, that room so that in case there is a problem, your data doesn't disappear while you're trying to address it and get it consumed. The other cool thing is dead letter queues. So you can configure your queue that if a message has been attempted too many times or it exceeds a certain age, that it gets promoted into the dead letter queue. So let's say, hey, look, I've tried to process this 10 times, and it's just my Lambda just keeps failing. So let's just stop it and move it to the dead letter queue. So you can configure that, or you can say my message is older than the days you have configured for retention, promoted to dead letter queue. There's one caveat here. The age of your message doesn't change when it goes into the dead letter queue. So if you configured your SQS queue for 4 days and your dead letter queue for 5 days, you're really just buying yourself 1 extra day. So you want to make sure your dead letter queue, if you have one, has a much longer retention window, because otherwise it will forget, and then it didn't really serve the purpose you had. So just remember, the dead letter queue, the age of the message in the dead letter queue is actually the original message timestamp when it was created, not when it was promoted. Now, the downside is if we want to follow this pattern of storing and emitting, we have to basically write our Lambda, as you saw, in such a way that it does both. And that's not great. That means that we now have combined failure modes, which is not awesome. The other thing is you can only do batches of at most 10. So if your intent is to batch things together when you store them, you don't really get a whole lot, right? You're going to end up with a lot of small files in S3, and that has its own set of problems. So I just remember that I forgot to show what sending to, what it looked like, sending Firehose, which is virtually identical, it's just a different call compared to Kinesis. We just give the delivery stream and the records. There's no partition key we need to worry about. And then for SQS, it's a little bit more complicated because SQS has a limit of 10 messages at a time. So we had to do batching here. This just parses out again the queue name, and then we have to send it in batches of up to 10. So as long as we have records, we send 10, 10, 10. And again, that's just, SQS queue is not designed for really shoving a lot of data in its direction, but it scales up pretty nicely concurrently. So it does a lot of other things really nice, and it's definitely something we use a lot. Cool. Okay, so cost comparison before we move on to the other pattern. When it comes to running these services, I just took a baseline. I mean, this was 1 terabyte worth of events per month, not compressed. So 1 terabyte of data that you're shoving through. So 10 terabytes if you compress it, and you have a 10x compression ratio. Kinesis is the cost-wise actually the clear winner. It ends, as you said at the bottom, at $11 per month. It's actually over provision. It could be pushing through 2 terabytes. It's about 60% of 1 terabyte. So just slightly under 2 terabytes of data you could be pushing through if our math is correct. You do pay per puts, so you definitely want to do what I mentioned earlier, where you collect together on your process as many records as you can before you push them into Kinesis. You also want to compress them for better throughput. But in terms of cost, it's really, really good. It's super performant. Like I said, 100 milliseconds before you get invoked on the back end, and it's pretty cheap as well. That said, you cannot drop the cost to 0. You need to provision 1 shard at least. It's around $7 a month. The rest of the cost, the $4 that were added, were because of all the puts needed, which are counted in millions of 25 kilobyte puts. Why is 25, not 16 or 32? The The only other place I've ever found as much imagination in pricing is the Harry Potter novels. AWS is definitely has the market on really lots of imagination in the pricing models. Kinesis is actually quite, Firehose is quite expensive in comparison. And one of the reasons here is that like almost 40% of the cost is actually in the transformer function that doesn't do anything really. All it did, it was reading the payloads that's going to get stored in S3, see if there were any events, emit them, and then send it back just the way it had received them. So it's kind of expensive. It would be interesting to see if hooking it up to S3, what is the invocation cost there? I suspect it's going to be a lot cheaper, but you're going to have even longer delays because the batch size that the Lambda function gets invoked with, I don't think is correlated necessarily to the batch size that you store in S3. And in S3, then you can store a much larger object, which is kind of nice for afterwards for processing. But again, that causes a lag. So depending on how fast you want to react to these things, may not be the right pattern for you. And then lastly, SQS, again, also price-wise really interesting. More expensive than Kinesis, again, drops to $0 if you're just not using it. So if you're using it a lot, it gets more expensive than Kinesis. But if you're not using it a lot, it's just going to be cheaper. It's going to drop below that $7 very, very quickly. I mean, pushing 1 terabyte of data through SQS is a feat. So that's it on the high level. So in terms of like these 3 services. Now, the way I like to combine them, and already kind of pointed at it, is not emitting to one SNS topic, it's just a copy, but actually emit to multiple SNS topics. So let's say we have a stream. And in this case, what I set up was a stream that has create, update, and delete events. And when the emit function gets the events, it will inspect the JSON payload and then forward it to the appropriate topic. Now, your handlers that you wanted to handle can use SQS queues to subscribe just to the topics that they care about. And that's kind of like the scatter gather pattern. So you scatter your events across all event types. And then when you build an application and it needs, for example, the create and the update events, you just subscribe to those queues. You don't worry about delete events. And when you create something that cares about create and delete events, because maybe it does provisioning, you just subscribe to those. So if you have some event types, and that's often the case at a much higher volume than others, these will not go to your application unless you actually care about them. So it's a really nice pattern. And it also means that you have decoupled the ability of adding more functionality to your environment without having to do any changes to the part that was responsible for creating all of these. So let's take a quick look at that. Let's get together. Let's take a look at the module. So because, oh, I'm not sure it doesn't deploy it. Wonderful. I use the import notation with Lambda Sharp to basically import the, in this case, I care about the create and the updated, like the first one in the example. And I say, hey, from this module, Kinesis stream, I want the content created topic on, and I want the content updated topic on. I create my receiving queue. I then have a queue policy that basically allows to those 2 topics to send messages to that queue. That's the policy. And then I have 2 subscriptions that I have to create. One is, again, to the create topic to deliver it to this queue. One is the update topic to deliver to this queue. And then finally, I have a process function that subscribes to the queue. And so it's going to get now just the events I care about. We could technically have the events, the topics directly invoke the Lambda function, but then you lose out on the nice retry mechanics that SQS has, right? Let's say you have a logic error, you're failing to process a certain message. Great, it's going to stay in your queue for a few days. You can actually deliver the fix, and it will catch up. Now it succeeds with those messages, and you can proceed. With SNS, not so much. They have introduced the functionality of dead letter queues for SNS now, but I don't have any experience, so I can't make a recommendation around it. Let's take a look at the process function. And this is where I ran a little bit into trouble because, like I said, even though I was expecting the event, which is what is being emitted initially, I had to say that I am listening to an SNS event, SNS message, which is the payload that SNS obviously delivers. And then once I got it, I could deserialize it. So this is still one I feel where that probably we can do better with the SDK, and just it's such a common use case that you have SQS subscribe to SNS that it does this unpacking for you and you don't have to worry about it. So to finish off, let's invoke again where we use the Kinesis stream. I think it's this one here. Yeah. So we emit again some events. Except now we have a stack that is subscribed to them. So we go back to CloudFormation, scatter gather, and I go to our process log functions. It got invoked. Right, that's the right one. It always surprises me just how fast this works, but because we wrote to Kinesis, Kinesis sent it to SNS, SNS sent to SQS, and it invoked our Lambda. And because Kinesis is so fast in delivering things, it's just, by the time you deploy it, you run a test, you go to your console, odds are I haven't really received messages. So again, you can see how it's deciding the messages. This is invocation counter number 6. At the 6th time this Lambda function gets called while warm, and it just does its thing. I didn't do any particular logging during the call. So that's kind of then how you can actually tie into your event-driven architectures by splitting out your events into event types and subscribing where you need them for your downstream handlers. And now you have nice decomposition of responsibilities, but you have a nice composable architecture, so you can extend it over time without having to worry about rebuilding more upstream components. Unless, of course, you introduce a new event type. In that case, yes, you will have to update this one. The other thing you get, because we use the import functionality from stacks, if I go to the stack here, and I look at exports, serverless, patterns, content created topic. Let's see which one is that. That's the Firehose. Let me find the regular one, Kinesis stream, created topic. You can see that it's being imported by the stack. So if I wanted to delete this stack, it would fail. You can't, because it has somebody dependent on it. Or if I wanted to delete the topic, I can't, because I have somebody dependent. So you can't break your message delivery architecture, which means you have a more reliable system, you have more checks in place. It's just healthier, in my opinion. It's a little harder to work with, but it just makes it more, it gives me more confidence I'm not breaking something accidentally, or the system will prevent it. Great, so let's wrap it up. Ultimately, what you need for your event-driven architecture depends on the nature of it. I think Kinesis Stream is very, very attractive, but it does have that minimum cost of months of $7. So if you build apps for fun and you have 10 of them running, suddenly you find yourself with a $70 per month bill. Not a fun place to be. You're better off using Firehose or SQS then for experimentation. Firehose has a nice benefit around the archival capabilities, which are really good. But I think in this event-driven architecture, it's not really what we want, because the speed at which it reacts, the lag is just really, really long. The cost is higher, so it does have some drawbacks. I'm a big fan of this architecture of fanning out to multiple topics and then subscribing to the ones you need, your queue that needs them for the reasons I mentioned. And I also need to compare and contrast it to EventBridge here, because EventBridge is definitely technology I'm very fond of. We didn't talk about it today. It's another way to do event-driven architectures, but it is completely loosely coupled, meaning you emit events into an event bus. There's a default one that gets created. You can create multiple. And you have no idea who might be subscribing to it. It's entirely based on the pattern matching language, the event rules that then triggers things from being delivered to Lambda function to the SQS queue and so on. So it's very open-ended. It's very, very flexible. So it has its place. And I think when you do partner integration and you just need to provide them a means that they can hook up their behaviors to it, it seems like a really great choice. However, for your own architectures, where you may want to be a little bit more strict, and if you're a fan of C#, you're probably a fan of typed programming languages, getting that machine validation as part of your infrastructure topology deployment, so that you can break things and that you can see who is subscribing to what. I think that's a huge, huge win. And I think the complexity upfront of kind of like saying that you need to import these topics, subscribe to them, is absolutely worth it. There's another thing, and this, look, limits always change over time. So today this statement may be true, and by the time you watch this, it may just not be. Right now, there's a hard limit per event bus of 2,000 rules. By default, it's 300, but if you reach out to your account manager, they can bump it up to 2,000. That's it. That's your hard limit. This limit is shared with cron jobs and all your other CloudWatch rules. So anything that you have running that might be triggering on alerts, on cron jobs, on so rates, or in this case on EventBridge, contributes to the 2,000 limit. That's not a great, that's you can get that pretty quick. I mean, we use 2 of them just for one little model. If you have a system that has 100 of these, you already have used 10% of your quota. And that's a hard limit. SNS subscriptions, in comparison, one SNS topic can have 12 million subscribers. Odds are, if you're using it to connecting subsystems, you're not going to run into this. Now, again, EventBridge, they'll probably evolve it. You could have used multiple event buses. You can use it with multiple accounts. So there's ways of going around it. But I feel today, SNS topic, especially when it feeds into SQS, has a huge reliability component to it. They will try to deliver that event into SQS for days. If there's some problem with the SQS service, SNS will not forget about it. It is the better choice for having a reliable architecture. That's my take right now. And EventBridge is more open-ended, so partners, you just don't know what they need. Absolutely, this is a really great opportunity for making integrations possible and being very open-ended. That said, once you admit it, you can never take it back because you don't know who might be dependent on it. So backwards compatibility can only be ensured by never modifying anything you've admitted, or certainly not taking it away. Great. That's it. The samples with hopefully the corrected S3 Firehose configuration will be posted right after this. I hope you enjoyed it. And if you have any questions, you can reach me at lambda sharp on Twitter. Thank you very much.